Alright guys, welcome back. We're going to be solving out a question from the second chapter of the Engineering Mechanics by Meriam. And in the first few lines of this question, basically the question explaining the application of this truss that we see on the right hand side. So the asymmetric roof truss is one of the type used when a near normal angle of incidence of sunlight onto the south facing surface ABC is desirable for solar energy purposes, and the 5 vertical loads represent the effect of the weights of the truss and supported roofing materials, and the 400 newtons that we see at point B represents the effect of wind pressure. So we need to determine the equivalent force couple system at A, and also we need to compute the x-intercept of the line of action of the system, resultant treated as one single force R. So for the force couple system, or first part of this question, basically we need one resultant, which is basically the sum of all forces that we have in the question. And if we look at it, we have x and y defined in the figure, and we can see all the forces are in y direction except the 400, which was the effect of the wind. So we can resolve that force into two components. And for doing that, we know this angle is 30 degrees, which means this angle here is also 30 degrees. So if we want to find the forces, so let's start with the x component. The only x component is the effect of wind, which is 400 cosine of 30 degrees, and it will be positive, so that's the only I component. And for the J or the Y component here, basically have 1 2 3 500 downwards, so negative 3 500. We also have 250 at A and F, so negative 2 times 250. And the last one is the y component of the 400, also downward, so 400 sine of 30 degrees, and that's going to be our J. And all the forces are in newtons. Let's just calculate what we get in here. So for the x, we have 400 cosine of 30, which is 346. And it's going to be negative 1500, negative 500, and sine of 30, we know it's 0.5, so negative 200, and that's going to be negative 2200 J, and that's going to be in Newton. So that's our force for the force couple system. And since we have to find the force couple system at point A, we need to find out the moment or sum of all moments about A. With the sign convention that we have, counterclockwise positive. So let me just clean up the figure. So the 250 newtons is not going to make any moment, but we have the moment of the 400. And because the 400 is already perpendicular to this side of the truss, so what we're going to do, we just need to figure out this side. So we know in this right triangle, the hypotenuse is 5, which means this side is sine of 5 sine of 30, or 2.5. Again, sine of 30 is 1/2 or 0.5. So the moment of 400, we can see it's clockwise, so negative 400 times 2.5. Now let's move on to the moment of the 500 at C. This one's also clockwise. And the distance that we need for this 500 would be, this is the line of action, we're gonna need this. And the triangle that we have in here, this one, all the sides are equal, so it's an equilateral triangle, and we figure out this is 2.5. And if we look at the bigger right triangle that we have, this one, the angle is also 30 degrees, and this is 10, which means this side is also 5. And if our triangle is equilateral, that means that the distance that we are looking for here is also 2.5. So that's going to be negative 500 times 2.5. It's going to be same story for the other one. 500 this time, the distance would be 5, so plus 5. And the last one would be this one. Again, same idea. This is going to be in the middle too, so the distance would be 5 plus 2.5, or 7.5. And the last moment that we have is the 250, so this one's also negative, and the distance is basically the green right triangle base or hypotenuse, which is 5 plus 5, or 10. And this is going to give us the total moment that we're going to get, 4000 times 2.5 plus 500 times 250. So yeah, this is going to give us negative 11,000 Newton meter, and the negative sign shows that the moment is clockwise. So that's going to be our force coupled system. Basically, we can just replace all of these forces with one single force, which is the R that we found in here, which is going to be in this direction, and one couple about A or MA, which we figured is negative 11,000 Newton meter. So that was the first part of the question. For finding the y-intercept, the x-intercept, we can see that this moment, in order to make the clockwise moment, that R has to be in this direction, and what the question is asking is basically this distance. And for doing that, we can resolve this force into two components. That's our R, or line of action of the R. We can see that the y component of R is going to make moment, which is this value here. So the MA has to be equal to the RY times X. So negative 11,000 is equal to 2,200 times X, and the X here going to be divided by 2,200, 5 meters, and that's going to be the X intercept. The question is not asking us, but again, if we continue this is gonna cross the y-axis somewhere in here. That's how we can find the y-intercept too. Same idea. This time our MA would be this time Rx times y. But that's not what the question is asking. Just in case if you guys are wondering how we find that, same idea. And yeah, that's pretty much everything for this one. Let me know if you guys have any questions. You guys take care. I'll see you in the next video. Have a good one.